All right, this next lesson is on what's called nuclear transmutations, or what's also known as nuclear transformation. So I'm going to put this down here. So transformations and transmutations. Essentially, what that means is that we're going to transfer something into something else. And we've actually already been looking at this. So this is really nothing new. It's just, you'll see why I'm talking about it in a second. Okay, anyway, so transmutation is what the alchemists were attempting to do. They wanted to turn lead into gold. Okay, so when we look at transformation, we're talking about transmutations, changing one thing to another. That's what we've been doing with these nuclear reactions. We've been changing one nucleus into another nucleus. So a transmutation, or I'm going to put this up here again, transformation is a reaction where we change one nucleus into another. So the conversion of one atom of one element to an atom of a new element. So we convert carbon into nitrogen, we convert element X into element Y. We've talked about natural transmutations or transformations already. That's what we call radioactive decay. Well, scientists got the idea that, well, maybe we can artificially transmutate. Now, this is what the alchemists wanted to do a long time ago, but they had no clue about atoms, let alone the ability to transmutate them into something different. So they were very clueless on how to actually accomplish this. But with artificial transmutation, what we can do is we can take high energy particles and bombard them with the nucleus. So high energy bombardment of nuclei with particles. So we take a nucleus here, okay, we got some sort of nucleus, and what we do is we take a little particle and boom, smash it into it. And this is what's done in particle accelerators, like Fermi Labs particle accelerators and the Large Hadron Collider. That's pretty much what they're doing in those super colliders. Okay, the particles that we tend to use for bombardment, meaning collision or hitting with this, that's what the bombardment is, taking these little particles and hitting the nucleus. We tend to take alpha particles, beta, neutrons, and protons tend to be the particles of choice that we shoot at the other particles. Now, in 1919, Lord Rutherford, this is the same Ernest Rutherford who did the gold foil experiment, and he was using alpha particles in that gold foil experiment. So he did a lot of stuff with radiation. He made the first observation of an artificial transmutation. That is, he took nitrogen 14 and collided it with an alpha particle and turned it into oxygen. So he transmutated nitrogen into oxygen. As a result, a proton was emitted from this collision. So he took a sample of nitrogen gas, so he had all this nitrogen gas particles in a container, so he had N2 gas, and what he did was he collided it, he shot in here some particles of alpha. So these alpha particles, I can make that a little better. And the alpha particles, when they collided with this, turned this into oxygen gas. So the new gas that we saw being formed was O2 gas. Okay, so that would be our transmutation or transformation reactions. Okay, so there's natural, which is what we've been talking about already, radioactivity in the natural world, and then artificial transmutation, where we try to force it to happen. Well, this led scientists to think, well, if we can do that, why couldn't we convert an element into gold? And actually, in 1980, Glenn Seaborg did this accomplishment. He found that you can transmute. Now, bismuth isn't lead, I'll give you that. But it's very close to lead on the periodic table. He was able to take bismuth and convert it into gold. So he created gold from another element. He did what the alchemists were trying to do thousands of years ago. Now, Enrico Fermi in 1932 says, well, wait a minute, I got an idea here. Maybe we can make elements that haven't even existed yet. So now he's going beyond the scope of what we know in nature. When he says, I bet I can get an element to be formed that we've never seen before by bombarding it. Here's how his idea worked. If he took a heavy nucleus, got this nucleus, all these protons, neutrons, and electrons in it, and you add another neutron to it, you shoot a little neutron particle and make it even heavier. So what you do is you create a heavy nuclei by adding a neutron to an already heavy nucleus. Well, that nuclei is going to become unstable. It's going to shoot out. Now, once this is created, it will emit a beta particle, and when it emits the beta particle, it causes the atomic number to go up. So the atomic number will go up, and as a result of the atomic number going up, you get a element that is bigger than anything we've ever seen before. So let me show you this. Now, he didn't actually accomplish this because he got tied up with World War II and the development of the atomic bomb. But in 1940, Irwin McMillan and Philip Abelson did this. They actually created the first trans-uranium element. So they took uranium-238, which at the time was the biggest element, and it is the biggest naturally occurring element. There is no element bigger in nature than uranium. They collided it with a neutron. Then it created U-239, which was too heavy. I mean, this is already super heavy, and it's already very radioactive. Now this, U-239, then goes through beta decay, and it increases the protons to 93. So we go from uranium to neptunium. And then neptunium on its own broke down again through another beta emission and created plutonium. And uranium, Uranus, Neptune, Neptunium, Neptune, and then Pluto for plutonium. Which, by the way, Pluto is not a planet anymore. It's a subplanet. Anyway, this is amazing because now we've got elements that have never existed, at least anybody has ever seen in the universe. They probably existed eons ago, but because they're so unstable, they all have radioactively decayed and emitted back down to the more stable ones that we have nowadays. So what he did was he created what was called, well, these two guys created, based on the work of Fermi, what are known as trans-uranium elements, and that would be elements after uranium. And all elements after uranium are radioactive, okay, which we already know that because anything above 83, 84 and above are all radioactive anyway. So anyway, none occur in nature, so these are not naturally occurring, and all of these have been synthesized in some sort of reactor or accelerator somewhere in the planet. Somebody has done this and created this, and this is still going on today. Actually, up until August, this August in 2013, element 115, uni-pentium, was actually discovered. So this is, uni-pentium was the newest element to be added to the periodic table. They still haven't named it yet, and that's what they're still debating about, but uni-pentium has been discovered using the methods of Irwin McMillan, Philip Abelson, and Enrico Fermi. So that would be your trans-uranium, or transformation, I should say, transformation or transmutation reactions. All right, I'll see you guys in class. Thanks a lot.